Hello friends, so in this video we'll be discussing general organic chemistry GOC. This is a very important chapter, and in this chapter you'll be you'll be getting 4 to 5 questions. Okay, and GOC is that chapter which is included in all the questions of organic chemistry. Every question in organic chemistry will have some part of GOC or isomerism like that. Okay, so let us start with it. Now see, when new organic compounds are formed, uh, it means that few bonds are broken and some few bonds are formed. Okay, when some say from the reactant to product, from reactant to the formation of product, what happens, few bonds are broken and few bonds are formed. Okay, so this breaking of bond this breaking of bond, it can be done in two ways. Okay, the first one is homolysis and second one is heterolysis. Okay, so homolysis or homolytic cleavage, it is nothing but, you see, in homolysis what happens, the atoms, okay, in a molecule, both the atoms should be same. Okay, means their electronegativity difference should be 0, means both the atoms should have same electronegativity. Okay, if the atoms have same electronegativity, then what happens, this bond will break, giving one electron to each atom. Okay, the bond between the two atoms will break to give one electron to each atoms, and it will result in the formation of free radicals. Okay, so always remember that homolysis always gives free radicals. Okay, homolytic cleavage always gives free radical intermediates. Okay, and for homolysis or homolytic cleavage, we do not require any reagent. Okay, only heat or sunlight is enough. Say wherever, say in those reactions now, wherever you will see that heat or sunlight is given, that means that reaction is a homolytic cleavage reaction. Okay, now let us come to the second one. It is heterolytic cleavage. Okay, one more thing, in homolytic cleavage, you see, since one electron is moving na, the bond is breaking and both the this one atoms are getting one electrons, so it is represented by a single headed arrow. Okay, arrow with one head indicates the movement of one electron, and arrow with two heads indicate the movement of two electrons. Okay, these things you should keep in mind. If it is one electron movement, then you will show with this arrow. If it is a two electron movement, then you will show it this arrow. Okay, double headed arrow. So let us come to heterolytic cleavage. Now see, in heterolytic cleavage what happens, the two atoms have different electronegativity. Okay, both the atoms should have different electronegativity. Say in this example na, electronegativity of B is greater than that of A. Okay, since electronegativity of B is greater than that of A, so both the electrons will be transferred to B. Okay, means since B is more electronegative, so it will pull the electrons towards itself, and both the electrons will move towards B, as a result of which B will have a negative charge and A will have a positive charge. Okay, so we will get cations and anions. Okay, so in heterolytic cleavage, the resulting ions are cations and anions. So these are the three different types of intermediates that are possible. Okay, so always remember that bond cleavage or bond fission is of two types, means it can take place in two types. One is homolysis or homolytic cleavage, which can be done when sunlight or heat is given. Another one is your heterolytic cleavage or heterolysis, which is possible when there is a difference in electronegativity between the two connecting atoms. Okay, so homolysis gives you free radicals and heterolysis gives you cations and anions. Clear? So let us discuss something about this reaction intermediates, the free radicals, cations and anions. So you see, carbocations, carbanions and free radicals. Okay, so these things are very important. Okay, because these are the intermediates, and intermediates always control the formation of products in organic chemistry. Okay, so you see, for cations first we will discuss. In cations, the carbon atom has a positive charge. Okay, so one positive charge means one electron is less in that carbon. Okay, so normally we know that carbon has 4 electrons. carbon has 4 electrons. Carbon has 4 electrons. Okay, so 1 electron will be less, that's why it will have a plus charge. Okay, so there will be 3 electrons remaining with carbon, and those 3 electrons it will use with 3 hydrogen atoms to form 3 bonds. Okay, so as a result you see this carbon in its octet, means sorry, in its valence shell, it has 6 electrons. Okay, so for cations you just remember these properties. First one, it is having a positive charge on carbon. Second, it has 6 electrons, means this carbocations na, the carbocation carbon has 6 electrons in its valence shell. Say it is like this, say 1 bond with hydrogen, 2 and 3. It can be with other carbons also or hydrogen also, anything. Okay, so the carbocation carbon in its valence shell has 6 electrons. Each bond is having 2 electrons, so total 6 electrons. Okay, then hybridization of this carbocation carbon is sp2. So sp2 hybridization means its shape will be like this, trigonal planar. Okay, its shape will be like this. Its hybridization is sp2 and the shape is trigonal planar. And one more thing you remember, that this carbocation carbons na, these are electron deficient carbons. Okay, because in the according to octet rule, an atom should have 8 electrons in its valence shell. Okay, but the carbocation carbon is having only 6 electrons in the valence shell. So you see, if this carbon is electron deficient, then if we have some group which can donate electrons to this carbon atom, then this plus charge will be stabilized, because this carbon is electron deficient. If you can have some group which can give electrons to this carbon, then this carbocation will be stabilized now. So always remember that electron donating groups, it stabilizes a carbocation carbon. Okay, or you can also say that electron donating group stabilizes carbocations. Okay, and lastly it reacts with nucleophiles. Now see, nucleophiles are electron rich species. Okay, so carbocation carbon, since it is an electron deficient species, so nucleophiles will always be more available, or say you can say that nucleophiles will be more reactive towards carbocations. Okay, because since these are electron deficient and nucleophiles are electron rich species, so there will always be a reaction between the nucleophile and the carbocation. Okay, and the last is your magnetic property for carbocations. Since it is having even number of electrons, means 6 electrons, and 6 electrons are all paired. Okay, means all the electrons that is present now in the valence shell all are paired. You see, these electrons all are paired in bonds. Okay, so all these electrons are paired, so no unpaired electron is there. That means it is diamagnetic in nature. Okay, so these are the 6 properties of a carbocation carbon. So always remember that these 6 properties you have to keep in mind. Okay, because these are very very important. GOC means all the small parts of organic chemistry, okay, which are being used in all the reactions. So those small concepts you have to know, because those things will only be helpful, or else you'll find organic chemistry very difficult. If you do only GOC isomerism part na, you can easily solve almost 10 questions in your exams. So let us come to the next intermediate, the carbon ion. Okay, so carbon ions have one extra electron, means carbon will have 5 electrons in its valence shell plus 3 electrons it will get from 3 hydrogen. So total it will have 8 electrons. You see this structure, this carbon, it is forming 3 bonds with 3 hydrogens. So and since it has one extra electron, so total in its valence shell it has 8 electrons, means the octet rule is followed in this carbon ion. Okay, means it is very very stable. Okay, now see, since this carbon, the central carbon, is having an extra electron, so it is having a minus charge. Okay, so there is a negative charge on carbon. This is the first point. Second point, there are 8 electrons in its valence shell. In the carbocation, what we had 6 electrons. In carbon ion it will have 8 electrons. Okay, then hybridization will be sp3. In carbocation it was sp2, trigonal planar was the geometry, and carbanion it is sp3, and geometry is tetrahedral. Okay, but you see one more thing, geometry is tetrahedral but the shape is pyramidal. Okay, geometry and shape I already explained in chemical bonding, because you see geometry, what do, we consider both lone pairs and bond pairs. Okay, both lone pairs and bond pairs of electrons are considered, but in shape we consider only the bond pairs. Okay, so if you look at this structure now, the structure of this carbanion, you see if you consider the all the lone pairs and bond pairs, it is a tetrahedral geometry. Okay, but while considering this one shape, we will not take this lone pair. Okay, so if you don't take this lone pair, means it is a pyramidal geometry. Okay, so in this way we find out. Then you see since it is a carbanion, means it is having a minus charge in it, means excess of electrons is there. Okay, so excess of electrons means carbon is having more electron density. Okay, so if you can attach any group to that carbon which takes electron, means electron withdrawing groups, if it takes electrons from the carbon, then the carbon will be more stable, because the carbon already have higher electron density, means it has excess of electrons. So if you add a electron withdrawing group, then it will be more stable. Okay, so electron withdrawing group, it stabilizes a carbanion carbon. Okay, similar next one, you see it also has even number of electrons, means 8 electrons, so all electrons are paired, so it is diamagnetic in nature. And since it is rich in electrons, so it will be reacting with electrophiles. Okay, so these carbocations and anions, their properties are just exactly opposite. Okay, just to keep in mind these things, only magnetic properties same, both have diamagnetic nature. Third one is carbon free radicals. Okay, these are neutral species, means it does not have any charge. Okay, it is just means the carbon will have 4 electrons and it will just react with 3 hydrogens, so 3 electrons will be used and 1 electron will be left in the carbon. Okay, so that's why it's called a free radical. And you see total it will have 7 electrons in its valence shell. Okay, 7 electrons means it is odd number of electrons, so it will be paramagnetic in nature because you have one unpaired electron. Hybridization of this carbon, it depends upon the original carbon. Okay, original carbon means say this one carbon, this free radical na, this is formed from methane. Okay, say it is formed from methane, then the hybridization of carbon in methane is sp3. Okay, so if a free radical is formed from methane, then its hybridization will also be sp3. If a free radical is formed from say ethene, okay, then its hybridization will be sp2. Similarly, from whatever hybridization of the original compound you have now, so the same hybridization will be reflected in the free radical. Okay, and since it is also electron deficient species because it is having 7 electrons, and according to octet rule atom should have 8 electrons in its valence shell. So since it is electron deficient, so it will be stabilized by electron donating groups. Okay, and it will be reactive with free radicals. So you just keep in mind that free radicals does not react with electrophiles or nucleophiles. Free radicals only reacts with free radicals. Okay, so these are the 3 different types of reactive intermediates that we'll be using or studying. So these are the very these reactive intermediates are very important. Okay, so let us come to the next part. So next topic is electron displacement effects. Okay, so you see in every chemical reaction there is some movement of electrons. Okay, so because of this movement of electrons only these reactions occur. Okay, so there are many effects that we have to consider for studying different reaction mechanisms. Okay, so first one is your inductive effect. Okay, the first one is your inductive effect. So inductive effect means what? You see, if you have a hydrocarbon chain, say this one, say let us take this first one. Okay, now if a electron donating group is attached to the carbon atom, say in the hydrocarbon chain you have a electron donating group attached. Okay, say for example you have this chain, and in this chain you have electron donating group, say you have OH. Okay, you have a electron donating group attached. Okay, OH. Now see, if a electron donating group is attached, it will give electrons to the first carbon, means whichever carbon it is attached, it will give electrons to that carbon. Okay, so as a result of which, if it gives electron or if it donates electron to the carbon, the electron donating group will have a partial positive charge because it is giving electrons, and the carbon will have a partial negative charge because it is taking the electrons. Means electron density at that carbon which is attached to the electron donating group will be higher. Okay, now you just so this effect na, this donation of electrons to the carbon atom on which the electron donating group is attached, this effect is called your plus I effect. Plus I effect means positive inductive effect. Okay, similarly, if a electron withdrawing group is attached to a carbon atom in a hydrocarbon chain, then it will take electrons from the this one hydrocarbon chain. Okay, if it pulls electrons from the hydrocarbon chain, what happens, it will have a minus charge and the carbon attached to it will have a plus charge in it. Okay, so this effect is called your minus I effect. Now this effect na, its intensity varies with the distance. Okay, means as distance increases the effect decreases. How it is so, say in this for plus I effect na, this electron donating group is attached to this carbon. Okay, so this carbon will have higher electron density because this electron donating group is donating electrons to this carbon. Okay, now it will also have some effect on the second carbon. Okay, but it will be less than that of the first carbon, and similarly it will also have some effect on the third carbon. Okay, so as a result, this electron donating group, its effect is effective only up to the third carbon. The first carbon, second carbon and third carbon, beyond the third carbon this effect is zero. Okay, means this effect is nullified. Okay, similarly for electron withdrawing groups also, the first carbon will have the most effect, means mostly affected, second one will have lesser effect of the electron withdrawing group, and third one will have the least. Okay, so after the third one the effect is zero. Okay, so this type of effect is only possible in sigma framework, means only in sigma bonds it will be effective. Okay, say means only in hydrocarbon chains or the carbon skeleton this effect is possible. Now two things you have to keep in mind, that the distance is very important factor for this inductive effect. Okay, as distance increases from electron donating or withdrawing group, the inductive effect decreases. Okay, and secondly, it operates through sigma bonds. If you have a pi framework, then this effect will not be means available. Okay, say inductive effect only this one operates through sigma networks or sigma frameworks. Okay, so this plus I effect is possible when electron donating groups are there, and minus I effect is possible when electron withdrawing groups are there. Okay, so as a result of this thing, you have to memorize these two charts, say these two orders. Okay, so this is the first one is a list of the plus I groups, and the second one is a list of the minus I groups. Okay, and these are arranged in order of their say intensity. Okay, or power, means so which of this electron donate, say these are all electron withdrawing groups. Okay, and these are all electron donating groups. Okay, so electron withdrawing donating, you just have to keep in mind, you see this for minus I effect I have given now, this electron withdrawing groups, it decreases this side, so in the later half of this part we have electron donating groups. Okay, so this minus I effect or minus I groups na, it these groups have different intensities, means some are more electron donating or some are more electron withdrawing. Okay, so on the basis of that strength this order is made. So you just memorize this order because this is very important. Say what they can do na, in the exam they can give you questions. Okay, they will give you four structures, four molecules, and they will ask you which one has higher electron donating effect or higher electron withdrawing effect, like that, or stability of which carbocation will be higher or which will be less, like that. Okay, because just now while discussing carbocations anions na, what we found that electron donating groups, it stabilizes a carbocation an electron withdrawing group, it stabilizes a carbanion. Okay, so on the basis of this different groups na, this power of different electron donating groups, we can find out that which group will stabilize a carbocation more and which will stabilize a carbanion more. Okay, so on the basis of those things the questions may come. Okay, so we'll discuss the stability of means these applications of these effects also. So let us move on to the next effect. So the next effect is nothing but your resonance. Okay, resonance, I think all of you have heard of it and studied also, because this effect is very important, and resonance you will find in inorganic also, organic also. So resonance is not an effect, actually it is a phenomena. Okay, so resonance is a phenomena of delocalization of pi electrons. Means the pi electrons that are present in a system can be delocalized, means they can change their positions. Okay, and there are some conditions means first condition is that for resonance you should have conjugation. For resonance you should have conjugation. Okay, first point is conjugation. Second condition is you should have planar structure. Okay, means you should this framework or the system should be planar. Okay, so if these two conditions are present, then only resonance is possible. Okay, so what is resonance actually? You see this one, say this system na, the first example it is like this. Okay, so conjugation means what? Alternate double bond and single bonds. Okay, say you have a double bond, then you have a single bond, then you have a double bond, and then single bond. Okay, so if you have this type of system now where alternate double bond and single bond are present, then the system is called to be conjugated system. Okay, so conjugation is nothing but your alternate double bonds and single bonds. And planarity is also a factor that is important. Planarity means, you see, if you have a double bond, okay, double bond means the hybridization is sp2. Okay, you just keep in mind that if you have carbon carbon double bond, hybridization is sp2. If you have carbon carbon single bond, the hybridization is sp3. If you have a carbon carbon triple bond, the hybridization is sp. Okay, so these are the three things you should remember. So sp2 hybridization means what? The geometry is trigonal planar. Okay, means you will have a planar structure. So just keep in mind that if you have double bonds and single bonds in alternate position, then conjugation is there, plus the structure is also planar. Okay, so what can happen, you see, in this structure now, this double bond means this pi electrons can move on to this bond. Means first, always remember that in drawing resonance, the first arrow always moves from a double bond to a single bond. Okay, and the second arrow moves from a double bond to a atom. Means first arrow always ends up in a bond, and second arrow always ends up in an atom. Okay, this thing you should write, means you should note it down, because this is the most common mistake that all the students have seen, that many students they do this common mistake. Okay, first arrow will end up in a bond, second arrow will end up in an atom. Okay, say this one, the double bond will break and this electrons will be transferred to the single bond. Okay, and second arrow, you see, this bond, double bond will break and it will come in this atom. Okay, so as a result of this, what you will get? You will get this one, you will get a minus charge in this atom and you will get a double bond here. Okay, why minus charge? Because this pi electrons are moving to that atom, so that atom will have a this one higher electron density, so minus charge. Okay, so this is the example. You just take this example, you can draw it like this also. Just I have skipped 2 steps. Say first it will come like this, and then you can show this will come here and you will get this structure. Okay, so this is the full resonating forms for this molecule. Okay, secondly, you see benzene, it can be possible to draw in 2 forms. One is this one is this one. Okay, and both these forms are contributing 50-50% to the original structure of benzene, that is called your resonance hybrid. Okay, So both are equal because in both this you have 6 carbon atoms and we have 3 double bonds. Okay, and all the carbon atoms are sp2 hybridized. Okay, so resonance, you just remember that resonance is just a phenomena of delocalization of pi electrons, and it is possible only if conjugation and planarity is available. Okay, and while drawing resonating structures, always keep in mind first arrow will go from double bond to a single bond, and second arrow will go from a double bond to the carbon atom. Okay, next you see, let us discuss these two different types of resonating structures. Now see, before discussing these resonating structures now, I'd like to discuss the different types of conjugation that are present. Okay, so conjugation, it is of 6 types. Okay, means 6 type means, you see, that there can be conjugation between a double bond and double bond. Say double bond single bond, double bond single bond, means like that alternate double bond single bond if you have, that is one type of conjugation. Like that you will have different types of conjugation. Okay, the first type of conjugation is between a double bond and a minus charge. Okay, now if a double bond and a minus charge are in alternate position, then there will be then it is called negative charge and pi bond conjugation. Okay, how this is possible, you see, first one is this one. So this minus charge na, means extra electrons, it can donate its electrons to this at bond. Okay, and this pi bond can open up and give its electrons to the nearby atom. Okay, so we will get this structure. Clear? So this is one type of conjugation. Second type of conjugation is that you can have a double bond with a lone pair. Okay, double bond with lone pair. So lone pair means also excess of electrons, so it also can give its electrons to the bond, and the next pi bond can open up to give its electrons to the atom. Okay, so this is called your lone pair and pi bond conjugation. So you will get this structure. Okay, now see, the third one is your the pi conjugation, means two pi bonds are in alternate position. So this will give here, this will come here, and you will get this structure. Okay, fourth one is pi bond and positive charge. Say you have a double bond with a plus charge in alternate position. Okay, so plus charge means deficient of electrons. Okay, means it does not have any electrons, it is deficient of electrons. And double bond or minus charge means excess of electrons, or lone pair is also excess of electrons. So in this case, what will happen, this pi bonds will give its electrons to this single bond, and you will get this structure, means plus charge will come here and this position will be double bond. Okay, now one thing you should keep in mind, that while drawing resonance now, one more point you have to note down, that arrows, they move away from minus charge or lone pairs. Okay, arrows move away from minus charge or lone pairs, and arrows, it moves towards plus charge. Okay, see, in this one, first structure, minus charge is there, so arrow is going away from minus charge. Okay, second structure, you have lone pairs, so arrow is going away from lone pairs. Okay, now in the fourth structure, you see, we have a plus charge and arrow is going towards plus charge, because lone pairs, minus charge, they are rich in electrons, so they will donate the electron. So that's why what happens, arrows will go away from lone pairs or minus charge, whereas plus charge is deficient of electrons. Okay, so some other thing will donate its electrons to the plus charge, that's why arrows goes towards positive charge. Okay, now next one, the fifth one is pi bond and free radical. Okay, so pi bond and free radical are also possible. Say you have a pi bond and you have a free radical. Okay, pi bond and a free radical. So what happened in this case, you see, this pi bond will split up like this, means single arrow mechanism. This one electron will move in the single bond, and pi bond will give one electron to the single bond, and one electron will be transferred to the nearby atom. Okay, so as a result of this, you will get this structure. Okay, so this is homolysis. And this is, since it's a free radical, so single arrow mechanism. Okay, so this is also possible. And the last type of conjugation is lone pair and positive charge. Say you have this type of system. say any system like this, NH2 nitrogen has a lone pair and you have a plus charge. Okay, now we know that plus charge is electron deficient and lone pairs are electron rich, so lone pair will give its electron, say the plus charge will not be here, plus charge will be here. Okay, so in adjacent position if you have plus charge, so lone pairs will give its electrons and you will get this structure. Okay, so these are the 6 different types of conjugation that are possible, and this is very very important. Okay, so these are the 6 different types of conjugations that are possible. So let us go back to the resonating structures. Now you see in resonance what we have, say we have just now here I have written 2 examples for you to understand that 2 different types of resonance are possible. One is means in one arrows will be going away from the ring and the other one arrows will be going towards the ring. Okay, now you see in this first one, now it is phenol. Okay, the first one is phenol, and phenol, it is a electron donating group. Phenol is a electron donating group. Okay, now see why phenol is a electron donating group, how we will find it. See, electron donating and withdrawing groups, now if you don't memorize, then also you can easily find it. Okay, how to find it, you just check that this oxygen, it is more electron negative compared to the carbon. Okay, oxygen, it is this oxygen, it is more electronegative compared to this carbon. Now if it is more electronegative, it will pull electrons from this carbon. Okay, now this oxygen, if it pulls electrons from this carbon, you see this oxygen is connected to a hydrogen. Okay, and we know that oxygen, its configuration is 1s2 2s2 2p4. Okay, means only the second shell is available for oxygen. So since only the second shell is available, means no d orbitals are available. So if d orbitals are not available, the oxygen cannot keep the electrons, it will take it from this carbon. Okay, and also this oxygen has 2 lone pairs, means the oxygen already have electron density, so it cannot take more electron density because it does not have space to keep it. Okay, so as a result of which this oxygen will donate this electrons to the ring. Okay, now why it will donate, one more thing, that there is conjugation. You see this lone pairs of oxygen are conjugated with this double bond, because it is, you see, double bond, then single bond, then lone pairs, means alternate position there is a lone pair. Okay, so this lone pairs will donate its electrons and this pi bond will open up. This is the first step. You see, first arrow will go to the bond, second arrow will go to the atom. Okay, so you just like this. So you see in the second structure what we'll get a minus charge in the atom where this arrow is ending. Okay, and we'll have this one and double bond, and since oxygen is having 3 bonds, so it will have a plus charge. Okay, now you will just follow it. Okay, just this movement of arrows, now you will just carry on with this movement of arrows. Second one, what will happen, this minus charge will go to this bond and this bond will go to this atom, and this cycle will go on unless you get the first structure back. Okay, so this is for electron donating groups, means groups which donates electrons. So electron donating groups, I told you that arrows will be going away from electron donating groups. Okay, second one is what, second one is a electron withdrawing group. Okay, now in this one you see nitrogen, it is having say higher electronegativity than oxygen. Okay, and you can also say, ask the same question, that nitrogen also does not have d orbitals, how it will keep the electrons like that. Okay, but you see this nitrogen is attached to 2 oxygen atoms, and oxygen are more electronegative compared to nitrogen. Okay, now since this nitrogen is attached to 2 oxygen atoms, so oxygen will pull electron density from nitrogen, as a result of which nitrogen will pull electron density from the ring. Okay, so that's why it is considered to be electron withdrawing group. Okay, so for this one, the first step will be like this. This double bonded oxygen will take the electrons from nitrogen, okay, and this pi bond will give electrons to the next bond, okay, because this nitrogen is already electron deficient, so pi bond is excess of electrons, so it will give electrons to the nitrogen, and this double bond will open up and go to the oxygen, okay. So in the second structure you will have this one. You will have a plus charge in the carbon from which the pi bond is broken. You will have a double bond, you will have nitrogen and two single bonded oxygens, okay, and plus charge on nitrogen and minus charge on the two oxygens, okay. And one more thing, the overall charge in the system will be conserved, okay, that overall charge should be conserved. You see, in the first structure we had 1 minus 1 plus, so it is cancelling out, so it is a neutral structure. In the second structure we have 2 minus charge and 2 plus charges, okay, so it is neutral because all the charges are even, okay, balanced out. Similarly for oxygen also, you see, in the starting structure we don't have any charges, okay, in the second structure we have a plus charge and a minus charge, so it is balanced out, okay. So for this one, the next structure will be like this pi bond will open up and give us electrons to this bond, and then plus charge will come into this carbon, okay, and this cycle will go on unless you get the first structure back, okay. So this is another type of resonance that you can draw, that is for electron withdrawing groups. And electron withdrawing groups, arrows will be going away from the ring, okay, and electron donating groups, arrows will be going towards the ring, okay. So these are the two different types of resonance that is possible. So here I have given you, means written some examples, so you can try these examples, and if you have any doubt you can show me, okay. So these are your homeworks, you just try this examples and show me. So let us come to the next topic. Yeah, next are rules for finding stability of resonating structures, okay. Now one more thing in this resonance, now you see these structures, now all the structures that we can draw, these are called your resonating structures, okay. This structure is not considered because it is same to that of the first structure, okay. So these four structures only will be considered. So these are the four resonating structures for phenol, okay, and these are the four resonating structures for nitrobenzene. Now what is the this one importance of resonance or resonating structures? First importance is that you can find out stability of a compound, okay. So how you will find stability of a compound means, if a compound has more number of resonating structures, say if an organic compound has a more number of resonating structures, then it will be considered to be more stable, okay. So that is very very important. The more number of resonating structures you can draw, the more stable the compound will be, okay. So in that way, what they can do in the exam, they can give you four structures, say four molecules, say they can give you phenol, then orthonitrophenol, paranitrophenol, metanitrophenol, like that, okay. And they will ask you which one is more stable, or they will ask you to write the order of stability for these four molecules. So that time what you will do, you have to draw resonance, okay. You can find stability by other forms also, say electron donating, withdrawing, inductive effect, and all different types of effects, all using all those you can find. But resonance is very very important for this aromatic systems, okay. Or if you have conjugated system, then it is very very important. One question also comes, I think it came in your class 12 exams also, why phenol is more acidic than alcohols, okay. So you see, if you have a normal alcohol, then resonance is not possible. Say if you draw just a normal alcohol, anything, just you take this one, this alcohol, okay. Now in this alcohol you don't have double bonds, okay, or you don't have conjugation, okay. So resonance is not possible for this alcohol, okay. But in phenol, you see, you can draw four resonating structures. So phenol is more stable compared to alcohol, okay. And stability is directly proportional to acidity. You just keep in mind, stability is directly proportional to your acidity. The more stable a molecule is, the more acidic it is, okay. So this is very very important. So that is why phenols are more acidic compared to your alcohols, okay. because when this H hydrogen atom will be given by this phenol na, the minus charge on oxygen will be stabilized by this resonance in benzene ring. Okay, so as a result this phenol is more acidic compared to alcohols. Okay, so this is important for your examination point of view. So you try to draw the resonating structures for this molecules and try to find out the order of stability also for 5 of them. Okay, so let us come back to the stability of resonating structures. Now see, a molecule can have many number of resonating structures. Okay, say 4 structures, 5 structures, 6, like that. Okay, so all the structures have different stabilities. Okay, among the resonating structures also you can find out stability. Okay, say they can ask you to draw resonating structures for nitrobenzene, and they will ask you that which structure is the most stable out of the 4 structures of nitrobenzene. Okay, so like that type of questions may also come. So for that we have few rules. Okay, the first rule, it says that non-polar structures are more stable than polar structures. Non-polar means the structure which does not have any charges. Okay, and polar structure means the structures which have positive and negative charges. Okay, so you see this one, this structure, it is butadiene. So in butadiene you don't have any this one charges. Okay, so it is non-polar. Okay, but if you draw the resonating structure for butadiene, it is this one. It is having a double bond in the central two carbons, and you have plus charge and minus charge on two ends. Okay, so this is a polar structure, and this one, first one, is a non-polar structure. So according to the rule, is again gone. So yeah, so according to the rule, this non-polar structures are more stable compared to polar structures. Okay, second rule says that if you have resonating structures which has same number of bonds, okay, then the structure in which all the atoms have octet fully filled out, means all the atoms which obey octet rule, that structure will be more stable. Now see, in the first structure, this carbon is having octet, this nitrogen is having 1 2 3 4 5 6 electrons. Okay, 8 electrons. This nitrogen is also having octet, but this carbon now, this central carbon atom, it is having 6 electrons. So 6 electrons means it does not obey octet rule. Okay, but if you draw the resonating structure, you see this nitrogen, then central carbon, and this terminal CH3, all the atoms are obeying octet rule. Okay, they are having 8 electrons in their valence shell. So as a result of which, this structure is more stable compared to the first one. Let me check once. I think it is wrong. 1 2 3 4. Yeah, this one will not be more stable. Okay, this one will be more stable. This one will be more stable. This will not. Okay, this one will be more stable because it is having octet rule. Okay, you just check once, count the electrons. If for all the atoms, hydrogen it will be 2, and nitrogen and carbon will be 8. Whichever structure has all the atoms 8 electrons, it will be more stable. The third one is neutral structure or less charged resonating structure is more stable. Okay, yeah, just like the first example, non-polar is more stable than polar, or neutral is more stable than charged. Okay, so in this one, first one is a carboxylic acid, it is a acetic acid, and second one is just a resonance form of the acetic acid. Okay, now in this first one, this no charges there, but in the second one, you see positive and negative charges are there, so the first one is more stable. Okay, the fourth rule says that if you have charges, okay, so if you have a plus charge or if you have a minus charge, then you should keep in mind that the structure in which the positive charge is present on an electropositive atom, say for example metals, sodium, potassium, these are electropositive. Okay, if you have plus charge on metals or electropositive atom, then it will be more stable. Okay, and if you have minus charge on electronegative atoms, then that structure will be more stable. Say for example, you have oxygen, you have nitrogen, fluorine, so if you have minus charges on these atoms, then the structure will be more stable. Okay, and the opposite is also true, means say if you have plus charge on electronegative atoms, it will be unstable. If you have minus charge on electropositive atoms, it will be unstable. Okay, so in this first structure, you see In the first structure you have a minus charge on carbon. Okay, in the second structure you have a minus charge on oxygen, so it is more stable because oxygen is more electronegative than carbon. So minus charge on more electronegative atom gives you more stable structure. Okay, and the last of this rules for stability is when you draw resonance na, those structures will be more stable where the positive and the negative charges are closer. Okay, first structure is neutral, so it will be the most stable, so order of stability will be this one first. Second, you see this one, structure number 2 and structure number 4, the positive and negative charges are closer to each other, so 2 and 4 will be second in stability order. And third structure, the positive and negative charges are far apart, so it is the least stable. Okay, so these are the 5 different rules for finding stability of resonating structures. Okay, so we'll end up this video here. In the next video we'll be discussing mesomeric effect, electromeric effect, and hyperconjugation. So thank you.